the way that it's worded is that you've got p of x and q of x. Those are just polynomial functions. That's it. Those are just plain old polynomial functions. And it's one divided by the other. And what we're going to be able to do is identify a bunch of parts from within those polynomials. Excuse me. There's a lot of little tips and tricks and things like that as we go through this that you guys will pick up on. Like, why do you have zeros for certain things? Why do curves go certain directions? Things like that. It's very fast to work with. One of the first polynomials that I like to, or one of the first rational functions that I like to show you guys how you graph is kind of the easiest one, 1 over x. So let's look at the graph of 1 over x. And what I want you to think about is when you first learned how to graph, you always graphed via a table. You graph via a table, right? All right. So here's what I want to do. If I pick a table, any table, I gotta change that color out of that later. Pick a value of x. 1. Okay. Well, let's do this. Let's start with -2, -1, 0, 1, 2. That way you get an idea of what's happening to it on both sides of the equation. All right. Or I'm sorry, of the origin. If I choose -2, what's my value for y? -1/2. If I choose -1, what do I get? -1. What happens if I divide by 0?
Undefined.
Undefined. When you have a 0, if you divide by 0, if you get an undefined function, that's when we put what's called a vertical asymptote. Vertical asymptotes are dotted lines for where something equals 0, or where it's an undefined value. Okay. Whenever you divide by 0, you put an asymptote in vertically. Okay. The easiest way to do that is just, if it's on your axis, one of the things that I've done, because I don't like to use graph paper a lot of times, if I know that I have an asymptote at the origin at 0, I might just do this. Instead of it being like a vertically dotted line, like I would do if it was at 1, I would do this. Since it's already on that axis, sometimes it's easier to see if you just kind of slash it going down. Does that make sense? It's just a different way of representing it. So sometimes people see it's a little bit cleaner that way. That's all. All right. And then if I keep going, at 1, it's 1. At 2, it's 1/2 again. What happens if you divide by a fraction? What's 1 divided by a half? If I do a half, that means it's 1 divided by a half. That's 2. Because isn't that, I take 1 over, 1/2 is 2 to the -1. Isn't that's no longer halving? Move it up. So at a half, it's 2. At a third, it's going to be 3, 4, and so on and so on. So these graphs do this on both sides. It's a hyperbola turned sideways. It's a hyperbola turned sideways. We're mathing too quickly?
Yes.
Well, I'm trying to, I picked something very easy to work with. What's wrong? All right. Now, let's make this interesting. There's a whole lot of stuff going on. Don't write this down. Don't write this down. Okay. There's a whole lot of stuff going on. You have, what happens here is that you get asymptotes at your x-axis and your y-axis. Because if you think about this, will this graph ever get to 0? No, it's going to get infinitely closer and closer and closer. It's like, you know, if you got brothers and sisters, I'm not touching you, I'm not touching you, I'm not touching you. You go on from there. You know, it's the same deal. So you have horizontal and vertical asymptotes. And then you got your vertical. Oops. Your domain and range. Well, what's the only value in the domain you can't have for this? 0. Very good. Because where is your vertical asymptote?
0.
It's at 0. Very good. So what happens here when we start talking about domain and range? Your range is going to be all, your range is all the y values that it generates, and your domain would be all the x values. Now, obviously, it's all real numbers except at 0, okay? Because it's undefined there. Well, what happens when you move it around? And A, H, and K. Hey, this is going to be a familiar scene. A, H, and K. It comes back over and over and over again. So we have the function y equals A over x minus h plus k, where you have x equals h as your vertical asymptote, and y equals k is your horizontal asymptote. And then it's a matter of rough sketches. And when we get to the point of, once we know where our boundaries are going to wind up at, the rough sketch is really easy, because you'll be able to pick a value of x that makes sense for you to plot a couple of points. And that's what we're going to start working on, because that's a skill that you guys haven't quite used a lot or mastered quite yet, and that's you making numbers work for you. Get approximate values that make sense for quick substitutions, okay? Things like that. Now, what I want you guys to do with these things is I'd really like you guys to start labeling A, H's, and K. Like I've said, I think we've done this before where I had you guys label it out when we did quadratic stuff. As we get into, when we graphed radical stuff, we labeled it out. We got SAR and shifting, how that stuff worked. When we get to rationals, we label it out so we can see where our asymptotes are. When we get to exponential functions, we'll again be able to see where our asymptotes are going to be and where our shifts are going to wind up going. Logarithmic, natural log graphs, all of that, they all have A, H, and K. Then when we get to trig, guess what? Trig graphs, they have A, H, and K. It's kind of an awesome, fun, super awesome fun time. You guys are really bored today. Why?
Because we don't want to be here.
It's better to be now, not like in middle of the June. So let's look at this graph. Oops. Do you guys want a piece of graph paper for some of this? Sometimes it's not bad. You know what? Let me get you. I have some. It might not be a bad idea to refer to a few of these. One for notes and one for homework. Excuse me. Oh. No family spiking cold. Not fun. So what I want you guys to do is label out what you know. A is -2, H is -3, and K is -1. Remember, your H value is always going to be whatever the 0 is. I'll have a couple extras here or there. Counting's hard.
It really is.
I know. One of these days I'll learn how to do it. So label out your A, H, and K. Throw them in as your asymptotes. So you have asymptote at -3. I have an asymptote, vertical asymptote, or sorry, horizontal at -1. And now I got to pick values that are going to help make some sense out of this. The easiest thing to do is to probably pick a number that I can get a fraction out of that makes sense. For example, if I'm at an asymptote at -3, if I choose -4 for x, I get -2 over -4 plus 3, and I subtract 1. Well, what's -4 plus 3? It's -1. What's -2 divided by -1? 2. What's 2 minus 1? 1. So that means at -4, it is at 1. See what I'm doing? I'm picking numbers that are going to be easy to work with. Just finding out a couple of values. -4 and 1. Okay. Let's see. Well, let's do -5. What's -5? Yes, ma'am.
Wait, so your H and your K are always going to be your like vertical.
That's the cool thing. That's the easy thing about remembering that. Yeah.
Your vertical.
Your horizontal asymptotes.
Vertical and horizontal asymptotes.
And don't. It's tough to because you always say H is your horizontal, but H is going to give you your vertical because that's the 0 of the denominator. So it's opposite from what you want to think because horizontal goes left and right, but yet x equals a number is always vertical. So here you've got, if I use -5, okay, again, using some quick mental math, you'll see you have -5, you get -2 over -5 plus 3. Well, that becomes 1, right? Because this is -2 over -2, so it's 1. What's 1 minus 1? 0. So this side is doing this. Remember how all these guys are going to have these curves, these hyperbola curves to it? Since this one was going up, this one was below it, that means the curve is probably doing this. I've got 2 points. These branches will always be hyperbola style, okay? So when you get your asymptotes, you're going to pick a couple of values, and more often than not, you're always going to get, bless you, a couple of numbers that work out quickly very near to where your asymptotes are. So you shouldn't have to worry about some crazy values of decimals or anything like that. A lot of the stuff you can figure out in your head, really, okay? And then I branch to the other side. If I branch to the other side, if I choose -2, -2 and 3 is 1. -2 divided by 1 is -2. -2 minus 1 is -3. So I have -3 and -3.
-2,
Did I say? Yes, thank you. I meant -2, -3. So what I'm getting at here is I'm getting ordered pairs. And then I'll use -1. And if I'm correct, -2 divided by 2 is -1 minus, yeah, so you get -2.
Wait. Oh.
And this one's going out this way. So here's your ordered pairs that you're going to generate. Okay. For these style graphs with the hyperbolas, I'd like you guys to label out 4 ordered pairs, 2 on each side. And you should come up with, to be honest with you, I don't think you're going to get anything worse than maybe a halvesy or a third or something like that. Could you fudge that well enough on a graph? But you're listing it so you know what the actual ordered pair is. But by throwing this in, you can actually get it to go through. Now, could you have put all that in your calculator and looked at a table? Absolutely. But would I have you do that with a calculator on a test? No, I give you a dummy calculator for something. All right, I let you have a dummy calculator because yours does too many buttons. Okay. It's great to check it, make sure you're right. Just a matter of remembering how to type it in. Should have opened this earlier.
Always forget that.
I do. Then again, my computer, I didn't plug in my computer over the weekend and it died. Like you do. How is here's a day? Is finals that traumatic? Or the fact that people moved and went to different classes and all, is it like heartbreaking that you don't get to see Izzy every day, or Jolie's gone, and you guys, were they the ringleaders and were just so talkative? They were, weren't they?
Is he left too?
But we got Grace though, she's a talker, oh my lord, you guys are you guys are gonna hate her. I'm joking. Do you guys know her? Have you introduced yourself yet? No. That's not her style, sorry. She's too cool. Just keep saying it. Anyways, this thing doesn't want to work, so whatever. Sorry. Hints! Here's another thing that can happen. Sometimes we get a function that looks like y equals ax plus b over cx plus d, where it's not the AH and K style. This is a different type. What happens here is that you have x values in the numerator and in the denominator, and they are of the same degree. That'll be important starting up tomorrow. When we have these types of values where I'm sure you guys know how to use Pythagorean theorem. Cool. So let's see, we have y equals a x minus h plus k. Y equals, this is ax. Again, the vertical asymptote will always be the zero of the denominator. It'll always be the zero of the denominator. So you might have to subtract these, divide by c. It could be something, okay? But the vertical asymptote is always the zero of the denominator. Oops, I know how to write. It's always the zero of the denominator. And the horizontal asymptote is the coefficients of x divided by each other. Remember, this is for this style. These guys are the same degree. Okay. We'll have one, I don't know if we'll have time to get to it today, but we'll have another one where the degrees are different. And when the degrees are different, that's when we can actually calculate and find the slant asymptote. Very exciting. All right. So let's look at an example. Y equals x plus 1 over 2x minus 4. So the easiest thing to do here is obviously right away plot your asymptotes and then pick numbers. Pick numbers on either side. Okay? So when I plot my asymptotes, my vertical asymptotes can be at the zero of the denominator. So I figured that out. There's my zero. Okay. Be okay with that? So my zero's at 2. My horizontal asymptote is going to be at the at y equals the coefficients of x divided by each other. Well, what's the coefficient of x in the numerator? And the denominator is, that makes a 1/2. Okay. What's up?
So you're finding, so the way you found the vertical asymptote is finding the zero, so you multiplied it by 2. You plugged in 2 for x. And you found the zero.
I solved the equation 2x minus 4 is 0. What's the 0 of that? I just set that equal to 0. Whenever you find a vertical asymptote, it's always the 0 of a denominator. So I just set it equal to 0 and solve for x. Okay. That gives me my two parts. So what I'm going to do then is I pick values on either side of the vertical asymptote. That way I know whether or not it's going to be, you know, if you want to think of this in terms of quadrants, is it going to be quadrant 1 and quadrant 3 for the hyperbola, or this way in 2 and 4? Okay. That way you pick those values out so you know what direction things are going to be moving. So let's see. So I'm going to use, what is that? 3. I'll use 3, 4, and then what was on the other side? 1 and 0. I'll use those 3 x values to generate my y values. Okay. So what's 2 times 3? What's 6 minus 4? 2. So this is going to be something over 2. What's 3 plus 1? So here's my first order pair at 3 and 2. What's wrong, Chad?
Where'd you get 3?
I'm picking numbers on either side of the asymptote, because usually,
Okay.
usually what will happen is the first 2 numbers on either side, more often than not, are they going to be the easiest numbers to work with for substituting in, for doing a plug and chug. All right? Those are usually the quickest ones to work with. Do the same thing with 4. What's 2 times 4?
8.
What's 8 minus 4? 4, so it'll be something over 4. What's 4 plus 1? 5. So it's 5 fourths. So my second order pair is 4 and 5 fourths. 5 fourths is 1 1/4. You okay with that? So it's a smidge more than 1. Now, right away, I now know the direction of what this is going to look like. Since this one wound up being lower than the other one, it has to be doing this. That branch is going to do that. You okay with that? And I go to the other side, and I use 1. I get, if I use 1, my numerator is 1 plus 1, 2. Denominator is negative 2. You okay with that? So you wind up with 2 over negative 2, which is negative 1. So at 1, I'm at negative 1. 0 is going to be really easy. I get 1 over negative 4. And again, you now know what direction this is moving. There you go. I really want you guys to try and plot these 4 points without using a calculator. Because when I ask you guys to do this later on, I'm not going to let you use the graphing calculator to do this. Okay? Yes, ma'am.
So do you always just do like the couple that are right next to the the vertical?
Usually that's the easiest ones to find. You don't have to, but it's going to be easier to use those 2. It's just kind of like how we always graphed when you picked, you did linear stuff. You picked 2 numbers that are positive, 2 numbers that were negative about the y-axis. It's the same basic idea, but we've shifted the y-axis over to a new vertical asymptote. So you're picking numbers on both sides. That's all. It's usually the easiest way to find them. Okay. That was pretty quick. I actually got time to get to this third one. Nope. Well, that's right. We don't do the third one until tomorrow anyway. All right. Let's just do this then.
Do you want us to do it on the graphing paper?
Yeah, I think so. This is old book. We're probably gonna be sticking in the old book pretty much second semester. If there's anything that comes up, I know there's a couple of word problems about exponential functions that are in the new textbooks that are actually really good. I'll probably just make a photocopy of it and do that as a little handout. That way we don't have to do the 15 clicks of freedom. So, Trap, you got your Chromebook open, right?
Yep.
Double check, make sure that chapter 9 is still open. I think it is. I believe I left it all there.
What you do? just on the website?
Yeah, let me see if I can find it real quick, just to make sure it's working.